Hello, it's me Samin again. Today we are going to learn about firewalls. So let's not waste any time and get started. So today we are going to learn about these topics. What is a firewall? Why do we need a firewall? Data transfer, stream, packet filtering, types of firewall, and lastly we'll look at firewall rules. So let's now talk about what is a firewall. So here you can see it's your PC. This is a firewall, this is internet, this is server and hacker. So a firewall basically helps protect your network from attackers. A firewall shields your network because it acts like a 24/7 filter, scanning the data that attempts to enter your network and prevents anything that looks suspicious from getting through. A network security device or software acts as a barrier between your firewall acts as a network security device or software and acts as a barrier between your computer or network and the internet or other untrusted networks. It functions as a gatekeeper, monitoring and controlling incoming and outgoing networks based on predetermined security rules. A simple way to explain how a firewall works is to think of it as a security guard with intimate knowledge of millions of potential criminals. If the guard sees one, he or she keeps the criminal out of the building. Similarly, firewall protection comes from monitoring and regulating traffic that goes in and out of the network. This is accomplished using few different methods like packet filtering, proxy service, and stateful inspection. Firewall checks what's coming in and what's going out. It saves us from hackers and viruses. There are various kinds of firewalls. I will talk about them later. Before that, you need to understand a few concepts like data transfer, packet stream, etc. But first, we must know why we need a firewall. So why do we basically need a firewall? Let's talk about it. So the first thing is security. Firewalls are your first line of defense against cyber threats. They protect your network and devices from malicious software, hackers, and other online dangers. The second reason you need a firewall because firewalls enable you to control and manage traffic entering and leaving your network. You can define rules that specify which application services or devices are allowed or denied access. So access control is a very important reason we need firewall. Thirdly, we need it for privacy. Firewalls helps maintain your privacy by preventing unauthorized access to your personal and sensitive data. They also ensure that confidential information remains protected from prying eyes. Next, we need it for compliance. In many industries, regulatory requirements demand the use of a firewall to safeguard customer data. Implementing a firewall helps ensure legal compliances and avoids potential legal and financial consequences. Lastly, we need it for network performance. Firewalls can improve network performance by optimizing traffic management. They can prioritize critical applications, enhancing the efficiency and responsiveness of the network. So this is some reasons we need a firewall. So now we should understand about packets. Don't worry, everything will be clear for you if you watch till the end of this video. We're learning this because we need to understand this topic fully to understand how a firewall works. So here you can see a file named doc.txt. This is a big file which is divided into blocks. When we send doc.txt from system A to system B, it gets divided into packets. First C will go, then A, and then T. It gets basically divided into chunks. Furthermore, when I talk about packets, you need to understand that I have divided them into chunks and we are sending them from system A to system B. So these packets can be data or even viruses depending on the user who is sending the packets. So now let's talk about data transfer and how does data transfer happen. So suppose system A wants to communicate with system B. Let's suppose system A wants to download a file. So what system A will do is he will talk in FTP, which is file transfer protocol, that is running on port 22. And when data packets get transferred from system A to system B, there are some details inside the data. The details are source IP and the source port, also the destination IP and the destination port, and the protocol is also mentioned. So when packet travels from system A to system B, all this information is there inside the data. So nextly we need to understand what is stream. So suppose system A wants to send data to system B. Firstly, he needs to do a three-way handshake to establish a connection. So when a system A gets connected to system B, a connection is created. That is called stream. You can also call it data connection. So suppose C also wants to send some data to system B. It will be done the same way like the connection of system A and the system B was done. It will also create another stream. So this is the way system runs on multiple streams. So now let's look at the types of firewall. We can see that there are two types of firewall, software and hardware, and we can see a system A and system B. So suppose a system A wants to transfer data to system B, so there will be a program inside B, and if you are using a Linux, there will be IP tables, and if you are using Windows, there will be a thing called Windows Firewall. You can define rules here. Rules basically determine which packet will come inside and which packet will go out. Software firewalls are basically pre-installed in your systems, and in the case of hardware firewalls, there will be physically touchable things like routers. We can connect it to our system and determine rules like the software one. So don't get confused, because the both act the same way. So now let's talk about packet filtering firewall, or the first generation firewall, and understand how it works. So suppose system A is sending some packet to system B. A firewall is beside system B, and it checks the details of the packets, which are source IP and the source port, and the destination IP and the destination port, and the protocol. But there is a problem with the firewall, that it basically doesn't check the stream and also doesn't ensure if the three-way handshake is done or not between the system A and system B. It only checks the details and receives the packet whether it has any viruses or not. Packet filters are typically stateless, meaning they basically don't maintain information about the state of connections. So now let's talk about stateful inspection firewalls, or the second generation firewalls. This firewall basically has all the qualities of first generation firewalls, but the extra thing it does is it verifies three-way handshake, and system A cannot send packets to system B without doing a three-way handshake, and this is why it's called stateful. These firewalls maintain a state table to keep track of the state of the network connections, and also allows or denies traffic based on the context of the connection. This was all about the second generation firewall. So now let's talk about the circuit level gateway. Let's understand about circuit level gateway. This firewall is also known as the this is also known as a proxy server. Suppose system A wants to communicate with a system B. Inside this firewall, there is a circuit level gateway, or a proxy server, and if B wants to communicate with A, it first needs to make a three-way handshake with the proxy server. After that, the proxy on the behalf of a B will do a three-way handshake with the system A. After all of this, A and B can communicate. No one can send packets without doing a three-way handshake, and if they try, the packets will get dropped. But if someone makes the three-way handshake and then sends malicious packets, it basically can't identify it because it doesn't see what's inside the packet. So this is a disadvantage of a circuit level gateway. Now let's talk about the application proxy gateway, or the third generation firewalls. It has all the qualities of first generation, second and the third generation firewalls. And also this third generation firewall performs deep packet inspection. As you can see here, it checks the source IP port, destination IP port, protocol, three-way handshake, and it also inspects the packets. So deep packet inspection basically means it checks if it's malicious or not, and if the packet is malicious, it will drop the packet. Now let's talk about the next generation firewalls. It has all the qualities of first generation, second and third generation firewalls. So here you can see a system A, server, admin and device. It can be IDS or IPS. So let's talk about IDS. So IDS is basically intrusion detection system. So suppose A wants to send some file to the server, and this will go through the IDS, and the IDS will perform everything a third generation firewall does, and it also checks whether the packet is malicious or not. And if the packet is malicious, it will alert everyone of the malicious activity. Its work is to alert everyone. And the next thing is IPS. This is basically intrusion prevention system, and if a malicious traffic comes, its duty is to drop the network, or it drops the packet, or it isolates the network depending on the situation. So this was all about next generation firewall and the work of IDS and IPS. Let's talk about firewall rules. So firewall rules sets basically include source addresses, source port, destination addresses, destination ports, and a decision on whether to block or permit network traffic meeting those addresses and port criteria. So firewall basically is our first line of defense in network security against the hackers, malware or any other threats. And these firewall rules refer to access control mechanisms that stipulate how a firewall device should handle incoming and outgoing traffic in your network. They are the instructions given to firewalls to help them know when to block or allow communications in your network. So don't worry if you don't understand this right now. After seeing the examples, you will understand the firewall rules easily. So these are some Linux firewall rules. So if you want to view current rules, you will just write sudo iptable/l, and it will list down all the current firewall rules. So let's talk about this command briefly. So suppose you want to allow all the incoming SSH traffic which is on port 22. So the command will be sudo. It basically means super user do, and iptables is basically the Linux kernel's built-in firewall. This -a means that you are appending, and input basically means you're adding the rule. This p means protocol, and you're using the protocol TCP. /d port basically means the destination port, and the port is 22. And this is basically means the actions to perform when traffic matches the rule condition. So this is how Linux firewall rules basically looks like. These are some examples of how you can allow incoming HTTP traffic and allow incoming HTTPS traffic. You will get them very easily with Google search, so don't worry. So now let's talk about the best practices for firewall rules. So it basically, you can review the you should review the firewall rules regularly, because the cyber threat landscape is always changing, and therefore you must regularly review the firewall rules to ensure they provide optimal security against the threats. Reviewing the firewall rules helps you to be several steps ahead of the malicious cyber actors and remove rule anomalies and maintain the compliances. So next is keep tabs on firewall logs. So you should basically keep an eye on the firewall logs. It will help the administrator monitor the traffic flow and identify suspicious activities, and also proactively it will fix challenges. Monitoring firewall logs will give you visibility into your infrastructure, and it will also enable you to get to know about the network users and the nature of their activities. So the next thing is reducing complexity by categorizing firewall rules. Make the firewall rules structure simple and easy to manage by grouping rules with similar characteristics. This approach will reduce configuration complexity, and it will also improve ease of administration and will optimize the firewall performance. The next thing is implementing least privileged accesses. Do not basically grant users more privileges than necessary to perform their tasks. This ensures that only an authorized user can create a new rule and change security policy or gain access to specific resources. And make sure you block all the high risk ports. So we have come to the end of this video. So this was all from me today. I hope I was able to make you understand what is firewall and types of firewall. So thank you, and keep liking my videos and do subscribe. Goodbye.